Okay, so we're going to do properties of lines. Whoa. I do not like it when people mess with this. Sorry. Okay, let's see. I get it all set just the right size. Okay, we'll do properties of lines and their angles. Okay. Now, for today, what I'm going to do is I'm going to show these terms with lines that are not parallel. And then tomorrow, what we're going to do is basically ask the question, well, what if the lines are parallel? What can we figure out? So I'm not going to draw the ends of the lines, but we're going to start with just a basic, here are two lines, and here is one other line that's going through them. So this line that's cutting through two other lines, that's called the transversal.
Do you want us paying attention or writing down notes?
Both. You pay attention and write down notes.
Okay.
This is a transversal. So a transversal is a line that passes through two other lines. Now, it actually could pass through 3 or 4, but the minimum for us to talk about anything with these lines is going to be 2. And then tomorrow, like I said, the lines that are in green will be parallel, and then we'll have some things that we can use in some proofs. But today is mostly terminology, so that when I say transversal, you know what I'm talking about. So what's this line that's passing through these two lines?
Transversal.
The transversal. We'll call it T. And we'll call this line L and line M. Ladies, you paying attention back there?
Yes.
Okay, so we do have a few things that are definite. What do you know about these angles that I just marked?
They're vertical.
They're vertical, which means they are
Equal.
congruent. All right, so I could do maybe 3 hashes here, maybe 4 hashes here. Those are all vertical angles. So we do have vertical angles in the mix. Notice that they are across from each other. Some of you are just calling everything a vertical angle. No, look, look. They're across from each other. See, they're across from each other. They aren't next to each other. Right? These are across from each other. They're across from each other, so they're vertical. All right, so I just messed that up royally. All right, so I'm going to get all that in. We have our vertical angles. We also have some supplementary angles, right? This angle and this angle add up to what?
180.
And look, I have another pair. Look up. Those two add up to what?
180.
These two add up to what?
180.
Okay, look right here. 180. We have a bunch. Now I've gotten kind of frustrated with some of you because you like just keep on forgetting. Whenever you see this, whenever you see this, whenever you see this or this, you should think that these two angles are what?
180.
They are not equal.
Equal to 180.
They add up to 180. Okay, they add up to 180. All right, first new term. Alternate interior angles. I'm going to mark them on this diagram with a star. Those two are alternate interior. These two with the happy face, those are alternate interior angles. Alternate interior angles are inside the lines but on opposite sides of the transversal. Do you get what I'm saying? Do you notice how these two angles that are starred are inside, in between the two green lines, but they're on opposite sides of that blue line? Those are alternate interior angles. These ones with a smiley face, same thing. They are alternate interior angles.
Why don't you just mark them all with a star?
Well, because then that would be confusing, because then I would have these starred, and those are not alternate interior angles. Okay? Those are something else.
Are we gonna learn what that something else is?
Yes, we are. Okay, any questions on alternate interior angles? Okay? Going on to the next term. Alternate exterior angles. Alright? Just by going with the opposite of what interior are, these are outside the lines and on opposite sides of the transversal. So, right here and right here. Do you see how those are on outside of the green lines and they're on opposite sides of the transversal? Alternate exterior angles. And here's the sad face ones. They are also alternate exterior angles. They're outside the lines and on opposite sides of the transversal. Where I'm putting this triangle, what are those?
Those are alternate interior.
Alternate interior. What about this empty circle?
Interior.
Alternate what?
Interior.
Okay, you need to say the whole phrase. What about where I put this X and this X? What are those? Supplementary. Yes, those are supplementary. What about where I put this Y?
Supplementary.
What about this X that I circled and that Y that I circled?
Alternate interior.
Alternate interior. Okay, so there's lots and lots and lots of possibilities. Okay, any questions on alternate exterior angles? Okay, going on. Next is same side interior.
Oh, I thought the true words they said same side circle or whatever.
Same side interior. Okay, as the name implies, these are on the inside of the lines and on the same side of the transversal. Alright, so if I put a little triangle here, a little triangle there, those are same side interior. They're inside the lines and they're also on the same side of the transversal. And where I put my square here and my square there, those are also same side interior. They're on the same side of the transversal and they're on the inside. See, basically these terms define themselves. They're on the same side and they're on the interior. Alternate interior. They're on alternate sides of the transversal and they're on the inside of the lines. Alternate exterior. They're on opposite sides of the transversal, but they're on the outside of the lines.
There might be an exterior one of these.
Same side exterior.
Yeah.
You actually would have a definition for those. They would be this.
Yeah.
Those are same side exterior. Okay? Easy enough. Not one that we'll define because we're going to be proving things about those. Same side interior. Any questions on same side interior? Okay. The next one, corresponding angles. These are in the relatively same position. With respect to the line and the transversal.
Which is why they're called corresponding.
Again, these are all definitions. When we get to tomorrow and we have the lines being parallel, we'll actually be able to use this for something. For now, it's just practicing understanding the terminology so that when we go to do the proofs, you have some terms that you can use and not sound like you're a bonobo. All right, take a look up so that you can see where corresponding angles are. Notice that this is in the top left. You with me?
Yes.
Top left. This is the top left of the other line. Do you see what I mean? Top left, top left. This one right here, with the smiley face and the hair. Top right, top right. See what I mean? These correspond. Okay? This triangle, bottom right, bottom right. You getting what corresponding are?
Uh-huh.
Okay, square. Bottom left, bottom left.
So they're every point.
So, well, this one corresponds to this one. This corresponds to this.
Yes.
Here and here, those correspond. They're in the relatively same spots. You okay, Justin? I don't know what's so funny. Corresponding angles, they really get you going, huh? Huh?
The backing up feature.
Wow, we've never heard a truck back up before. Welcome to Sam's. Okay, whatever.
I'm trying to keep
All right, anyways. Any questions on corresponding angles? Yes or no?
No, sir. No.
Good. All right. Let's get a diagram. I'm about to.
It's a tic-tac.
Okay, anyways, get that diagram in your notes, and we're going to number our angles like so. Angle 1, angle 2, 3, 4, angle 5, angle 6, angle 7, angle 8, angle 9,
Wait, angle 2.
angle 11, 12, 13, 14, 15, 16. 16 angles.
Why?
I'm glad they're not candles.
K.
Well, I got 2 people know what I'm talking about, maybe 3.
I don't. I just like.
I watched that movie when I was little, and I was like,
I know what he was talking about. I didn't think it was funny.
All right. Name an angle that corresponds to angle 1.
Correspond. Angle 13.
No, angle 9 I meant, my bad.
Which one?
9.
Angle 9. Yes, angle 9 corresponds. Name another angle that corresponds to angle 1.
13.
Angle 13. Name and angle 5. Good job. All right. Name an angle that is an alternate interior to angle 7.
15.
14.
Angle 14. Good. There's one more.
Angle 10.
No, angle 10.
9. Sorry. I don't know.
Alternate interior. So we have this one and this one. But if I pretend this part isn't here, do you see angle 2?
Would it be?
Alternate interior.
Oh yeah. I see.
Ew.
No, I don't see that.
But angle.
Okay, look, ignore the bottom portion. Okay, here are my 2 lines. Do you see them? Are these on the inside? Yes. Are they on opposite sides of a transversal? Yes.
How
They're-
is 2 on the inside?
You got, okay, so I gave you your definitions with this.
Yes.
Think of it like this now.
Upside.
You can rotate it around. These are the 2 lines. This, okay, look at this green line. That's not green.
Oh, wow.
Okay. Look at this green line. There's my transversal. These are on opposite sides of the transversal. They're also inside this line and this line.
Oh, okay.
Couldn't all those lines be transversal?
So
It
number,
depends upon the perspective you're looking at it.
so number 10, angle 10 cannot be an alt.
It cannot be alternate interior to 7,
But number 2 can.
but number 2 can. All right, give me alternate exterior. Give me alternate exterior to angle 11.
Angle 11 is down there.
7. Angle 7.
2.
Okay, angle 7 would not be on the exterior.
Angle 1.
Angle 2.
Angle 3.
Angle 1.
Okay, whoa. Look where 11 is.
Oh. Angle 3.
Okay, so I'm definitely talking about this line, and I'm definitely talking about this line. 2
Oh.
is alternate exterior. There's another one.
10.
14.
Okay, how could 10 be, it's vertical. 10 is vertical to 11.
Angle 14.
16.
Angle 14 is alternate exterior.
Do I have to speak?
This is what you really have to do in order to see it. You have to basically cover up pieces of your diagram. You see what I'm doing? Okay, now I see that this green line and this green line are the 2 lines, and this one's the transversal. You see how 11 and 14 are alternate exterior? You have to basically cover up pieces of it. All right, give me a same side interior for angle 13.
Angle 10.
Angle 10, yes.
Angle 7.
Angle 7, yes.
Angle 4.
Not angle 4.
They're not
That's
I'll give an
also-
example of what not to do.
It's
They're
way
not
over
the same.
here, not at all related.
Exactly. You're a skinny guy.
Okay, give me a corresponding angle.
Is that all?
Give me a corresponding, yes, give me a corresponding angle to angle 16.
12.
Okay, angle 12.
8.
Angle 4.
Angle
9.
And angle 8. See, this is bottom right, bottom right, bottom right, bottom right. Okay, give me alternate interior for angle 10. 6 is way over here, not the
What are we doing? Alternate interior for 10.
Angle 3.
Alternate angles.
Okay, angle 3. See?
16.
Okay, 16 is on the outside of everything. So this is alternate
Angle
interior.
15.
Angle 15.
And hex 15. Oh, there.
See? They're on opposite sides of the transversal.
Did we already do 5?
Angle 11.
No, we cannot do 5. It's way over here.
We do angle 11.
God.
The angle 3 is in
God, stop. Stop with the extra talking.
What's your name?
Look, guys, look. What are those angles?
Vertical.
Vertical. They are not alternate interior. Listen to the definition of alternate interior. They're on the interior of 2 lines and on opposite sides of a transversal. So what you have to do in order to see these, here's your angle 10. You need to basically draw this. Here's your first possibility. This line right here is my transversal. 10 and 15 are on opposite sides. Looking down, you're not seeing it. Then I do not feel sorry for you when you don't get it. Right here and right here. That's my other possibility. Here's my transversal. Do you see it?
Mm-hmm.
Do you see how 10 and 3 are on opposite sides of the transversal?
Mm-hmm.
Alternate exterior. Give me an alternate exterior to angle
Double angle.
6.
Alternate angle 14.
Angle 14, no. Angle 14 is on an interior.
Angle 13, or no,
Three.
angle 15.
Angle 15, yes. One more.
1.
Angle 3.
Angle 1's not on the opposite
Angle
side of
three.
3.
I'm
Angle
sorry.
3.
Angle 15.
Angle 3.
We already did 15.
Angle 3.
I got one right.
So,
Okay, take out your book.
So many angles.